Everything you think you know about Saturn is probably wrong. While most of us were taught that Saturn is just the planet with rings, the reality is far more fascinating and strange. Saturn isn't just a gas giant with pretty rings, it's a dynamic world of liquid metallic hydrogen with a weather system that would make Earth's most violent storms look like gentle breezes. Let's explore what makes this ringed wonder one of the most misunderstood planets in our solar system. This is one of the first detailed images of Saturn, captured by the Pioneer 11 spacecraft in 1979. And these stunning ring shots? They're from the Voyager missions that followed shortly after. But these early glimpses only scratched the surface of Saturn's mysteries. The scale of Saturn is almost impossible to comprehend. While not as massive as Jupiter, Saturn could still fit about 764 Earths inside it. Yet despite its enormous size, Saturn is the least dense planet in our solar system, so light that if you could find an ocean large enough, Saturn would actually float on water. For a more relatable sense of scale, if Earth were the size of a grape, Saturn would be about the size of a basketball. For decades, scientists believed Saturn formed much like the other planets in our solar system. The traditional theory suggests that the early solar system was a swirling disk of gas and dust surrounding our newly formed sun. Over millions of years, particles collided and stuck together, gradually building larger and larger objects. Eventually, one of these objects grew massive enough that its gravity could pull in vast amounts of hydrogen and helium gas from the surrounding disk. This theory would suggest that Saturn has a solid core of rock and metal at its center, surrounded by layers of gas. It's a neat, logical explanation that made its way into textbooks worldwide. But as with many things in science, the reality has turned out to be much more complex. Our first major breakthrough in understanding Saturn came from the Voyager missions in the early 1980s. These spacecraft provided our first detailed look at Saturn's atmosphere, rings, and moons. But the real revolution in our knowledge came with the Cassini-Huygens mission, launched in 1997 and arriving at Saturn in 2004. Cassini spent 13 years orbiting Saturn, collecting data that would completely transform our understanding of this world. One of its most shocking discoveries was Saturn's hexagonal storm at its north pole, a perfect six-sided hurricane-like feature larger than Earth that has persisted for decades. Nothing like this exists anywhere else in our solar system, and scientists still debate what causes this geometric wonder. The hexagon isn't Saturn's only atmospheric mystery. The planet also hosts a massive storm at its south pole that resembles a hurricane's eye, complete with a well-defined eye wall. And periodically, enormous storms erupt in Saturn's northern hemisphere that can wrap around the entire planet, creating a band of turbulence that can last for months. These storms are powered by heat rising from deep within Saturn. Unlike Earth, which gets most of its energy from the Sun, Saturn actually radiates 2.5 times more energy than it receives from the Sun. This excess heat comes from the planet's interior, where gravitational compression generates enormous temperatures. But the real revelations came when Cassini began probing beneath Saturn's cloud tops. Like Jupiter, Saturn isn't really a gas planet at all. The visible clouds are just a thin veneer covering something much more extraordinary. Saturn's outer atmosphere consists primarily of hydrogen and helium, with traces of ammonia, methane, and water vapor. These gases form clouds of different compositions at different altitudes, creating the subtle bands we can see from Earth. The uppermost clouds are made of ammonia ice, while deeper layers contain ammonium hydrosulfide and water ice. As we descend through Saturn's atmosphere, the pressure and temperature steadily increase. About 1,000 kilometers below the cloud tops, something remarkable happens. The hydrogen gas, compressed by the enormous weight of the atmosphere above it, gradually transitions into a liquid state. This creates a vast ocean of liquid hydrogen that extends thousands of kilometers deep. This isn't like any ocean on Earth. The temperature here is hundreds of degrees Celsius, but the hydrogen remains liquid due to the immense pressure. As we descend deeper, the pressure and temperature continue to rise, and the liquid hydrogen begins to change its properties. At about 30,000 kilometers below the cloud tops, where pressures reach millions of times Earth's atmosphere and temperatures soar above 8,000 degrees Celsius, the hydrogen transforms into a metallic liquid state. In this exotic form of matter, the hydrogen atoms are so tightly compressed that their electrons break free and can flow through the material. This allows the liquid to conduct electricity like a metal while still flowing like a fluid. This metallic hydrogen ocean makes up the majority of Saturn's interior and is responsible for generating the planet's powerful magnetic field. As Saturn rotates, the flowing metallic hydrogen creates electric currents that produce a magnetic field 578 times stronger than Earth's. At Saturn's center lies something even stranger, a core that's nothing like what we expected. Traditional models suggested a solid ball of rock and metal, similar to Earth but much larger. However, recent research based on Cassini's gravity measurements suggests Saturn doesn't have a clearly defined solid core at all. Instead, Saturn appears to have what scientists call a fuzzy or dilute core, where rock, metal, and metallic hydrogen blend together in a gradient with no clear boundary. This core region may extend to nearly half of Saturn's radius, much larger than previously thought. How did Saturn end up with such an unusual core? One theory suggests that early in Saturn's history, its core grew by accumulating rock and ice from the surrounding solar nebula. As the planet grew, the increasing pressure and temperature at its center caused this material to mix with the surrounding hydrogen, creating the diffuse core we see today. Another possibility is that Saturn experienced a massive collision early in its history. If a large planetary body, perhaps several times Earth's mass, collided with the young Saturn, it could have disrupted and dispersed what was once a more compact core. The Cassini mission's final act was perhaps its most daring, a series of grand finale dives between Saturn and its rings, sending back data that revealed the rings are much younger than the planet itself. They may be only 100 million years old, meaning that when dinosaurs walked the Earth, Saturn's rings might not have existed at all. This discovery was shocking to planetary scientists. For decades, it was assumed that Saturn's rings formed along with the planet itself, about 4.5 billion years ago. The revelation that they're relatively young raises fascinating questions. What catastrophic event created them? Was it the destruction of a moon that strayed too close to Saturn and was torn apart by gravitational forces? Or perhaps a comet or asteroid that was captured and shredded? And those famous rings? They're not solid structures but billions of ice particles ranging from dust-sized to house-sized, orbiting Saturn in a sheet thinner than a sheet of paper relative to their width. Despite spanning more than 280,000 kilometers from edge to edge, the main rings are typically less than 100 meters thick. If you compressed all the material in Saturn's rings, it would form an ice ball smaller than one of Saturn's moons. The rings are organized into thousands of ringlets, with gaps created by the gravitational influence of Saturn's many moons. The largest gap, known as the Cassini division, is 4,800 kilometers wide and is maintained by the moon Mimas, whose orbital resonance clears this region of ring particles. Speaking of moons, Saturn has at least 83 known moons, each with its own unique characteristics. The largest, Titan, is bigger than the planet Mercury and is the only moon in our solar system with a thick atmosphere, denser than Earth's. It has lakes and rivers on its surface, but they're filled with liquid methane instead of water. Imagine rain falling from clouds, filling rivers that flow into seas, but in a world where water is as hard as rock and methane takes water's place. Another fascinating moon is Enceladus, which despite its small size, about 500 kilometers in diameter, is one of the most geologically active bodies in our solar system. Cassini discovered that Enceladus has geysers erupting from its south pole, spewing water vapor and ice particles into space. These plumes come from a global subsurface ocean hidden beneath the moon's icy crust, an ocean that could potentially harbor life. The moon's Iapetus and Hyperion present their own mysteries. Iapetus has one hemisphere that's as dark as coal and another as bright as snow, creating a striking two-toned appearance. Hyperion looks like a cosmic sponge, with an irregular shape and surface covered in deep craters. Saturn's moon system is so complex that it's almost like a miniature solar system, with moons ranging from tiny moonlets just a few kilometers across to Titan, which is larger than Mercury. Some of these moons are captured asteroids, while others formed alongside Saturn. Some orbit within the rings, creating gaps and waves, while others orbit far from the planet. One of the most surprising discoveries about Saturn in recent years involves its rotation rate. You might think this would be easy to measure, but Saturn has no solid surface we can track, and its cloud patterns move at different speeds depending on their latitude. For years, scientists used radio emissions to estimate Saturn's day length at about 10 hours and 40 minutes. However, Cassini's measurements revealed something unexpected: Saturn's rotation rate appears to vary slightly over time. This shouldn't be possible for a planet, as its massive bulk should maintain a constant rotation. The current theory is that Saturn's magnetic field, which generates the radio emissions we use to measure rotation, is somehow decoupled from the planet's interior rotation. The latest estimates put Saturn's true day at about 10 hours, 33 minutes, and 38 seconds, making it the second fastest rotating planet in our solar system after Jupiter. Saturn remains one of the most beautiful yet mysterious worlds in our solar system. Every answer we find only leads to more questions. It's not just a ringed planet, it's a liquid metallic world with weather patterns that defy explanation, rings that appeared relatively recently in cosmic time, and moons that could potentially harbor life. The next time you look up at that distant point of light in the night sky, remember, Saturn isn't what you think it is. It's far stranger and more wonderful than we ever imagined.